No, I have 10 minutes to go, 10 minutes to go. Let's do an example problem in decibels. Here we go. And then I guess we'll save Doppler for Tuesday. We almost finished, so close. But I don't want to rush Doppler out in 2 minutes. So Tuesday we will do Doppler and solve lots of problems. Doppler doesn't take that long. Maybe 15 minutes is all we need. Okay, so let's do an example. 500-watt speaker. Oh, big speakers send sound into a uniform hemisphere. We had this problem at Jones. Sound into uniform hemisphere. So you got to know what a hemisphere is. Half a sphere, all right? So this is kind of that problem I was saying. So here you got this big speaker. Oh, we love it so much, right? And its sound is only going forward like this. Oh, yes. And here's people trying to sleep, and they can't sleep. Oh, my God. Here's the RA's apartment over here. Okay. And so let's say what decibels at 10 meters away? What dB at 10 meters away? Right? Interesting. So we don't have the intensity. We've got to combine these things we've been doing. So if it's a hemisphere, we'd say, well, the intensity here, well, it's half of a spherical wave. So you say, you don't have to memorize a formula. You just sort of think about its power per unit area. What's the power? 500 watts. What's the area? Well, that power is being spread over half of a sphere. So 1/2 4 pi, and the radius of that sphere is the distance, the 10 meters. 10 meters squared. Did I really? Oh, no, I dropped it to 10 watts because 500 watts was crazy. Okay, sorry. Let's drop it. My numbers work with 10 watts. I don't know. I should have done 500, but I changed my numbers. 10 watts. And this is 0.016 watt per meter squared. 0.016 watt per meter squared. Now let's think what that means. Intensity changes as you move away. Just like the difference between this heater and that heater, or that heater, it changes as you move away. So the intensity here is not 0.016, it's higher, right? The intensity right here is 0.016. Out here it's lower, but we calculated it right there. So now we just need the decibels. Now we just plug and chug, right? How intense is it relative to the threshold of human hearing? It's 10. It's good to write the dB in there. Good times. Over 0.016 over 10 to the minus 12. Right? Let's plug in the equation. Always use 10 to the minus 12 for your reference in the problems we're going to do. And 0.016. And I get 102 decibels. So that's how loud it is. So the threshold of pain is 130 decibels. And I know that's what we usually want to get to, but we're not going to get there. Okay? So the problems you do, we'll do some next week. You'll see them on the homework. Things like this. Okay? Let's see. Doppler effect. Okay, so I'm going to give you two things I have to tell you. You have to listen, and then you can go. What were they? I'm going to think about them for 5 minutes. Hold on. No. I honestly, okay, one of them is we're misusing the word intensity here, okay? In real physics, MKS units, what we're talking about is called the irradiance. Intensity has to do with the power per unit angle, and the words get mixed up a lot, okay? So I'm not telling you you have to start saying irradiance instead of intensity. I'm just saying in the future, if you're doing some weird calculation with waves, and they start talking about steradians, that's because this book is using intensity improperly. It's using the very old-fashioned word for intensity. So see author, okay? Irradiance is really the word we should talk about. Oh, the other one was decibels. Okay, so now you think you can go to the stereo store and buy speakers. You know what you're doing. You don't know what you're doing, okay? So then there's decibel meters, or I'm sorry, decibel M, and M means millivolts. So in electronics, which also covers many orders of magnitude, the same idea is used. But what goes here, you don't know. In electronics, it's usually a 1 millivolt amplitude. So you'll see like an M right here. That's what a dBm is. And often when you're dealing with speakers, they're talking about the electronics, not the acoustics. It's very easy to get mixed up. So I've given you just the most basic introduction to decibels and how to use it in this class. But many different engineering units use decibels, and it's very confusing. And it's called decibel. I keep saying decibel. I don't know why. So.